Now we want to take a look at homework number 32 that's in MyMathLab. Let's just work through these problems and make sure that we understand how to work them. I may not look at every single one of these problems, but there are some things I do want to bring to your attention. Okay, so in this first one, it says match the following equation with the description of the parabola. Well, here's what we know. We know that's a parabola because of the square, and it's got a positive 1 for that lead coefficient, which means it's going to be opening up. The plus 9 is on the inside, so remember, inside is a horizontal shift opposite of what we see, so that means we're going to be shifting to the left 9. The plus 7 means I'm going to be going up 7. So that means if I'm going left 9 and up 7, that means my vertex is going to be negative 9, 7. And that's going to be one of these guys right here, and it needs to open up. So it's definitely going to be A. Opening down is wrong. Here it's not going down 7. It's not going down 7. Does not open down. No. And these guys are shifted to the right as opposed to the left. Check it. Good job. This is the same kind of question. Notice that you have a negative out here, which means it's going to be an upside down parabola. So it opens down. This means left 5 and up 8. So left 5 up 8 is negative 5 comma 8, which could be this guy right here, and it does say opens down. So I think that's going to be it. Let's check everything else. Oh wait, it says negative 8. That is not right. I need negative 5 positive 8, so that's going to be F. This is why I look at all the answer choices just to make sure we're reading it correctly. So that is left 5 up 8, left 5 and up 8, and opening down. Okay, looks good. And here, it wants to give the domain and range. Well, we already know that the domain for any polynomial function is going to be all real numbers. So negative infinity to infinity. And the range is going to be from bottom to the top. So this guy goes all the way down to negative 9. And we can even see that here from that number. So it's going to be bracket from negative 9 going up to infinity. Now the coordinates of the vertex. All right, so we see that we have shifted. You can either look at the graph over here. You can look at the function notation, and you can tell that we've gone to the right 2, and we've gone down 9. The equation of the axis of symmetry. Well, we've seen all kinds of videos for graphing quadratic functions, so we know that the x-coordinate for my vertex is what we're looking for here. Now, they already have the x equals part there written for the axis of symmetry, so you don't need to write that. You just need to fill in the blank 2. So x equals 2. The y-intercepts. Well, you can zoom in here, and you can see that it's crossing right here at 0, negative 5. Even if you didn't know that, you could plug in 0 into the function. So 0 minus 2 is negative 2. Negative 2 squared is positive 4. And 4 minus 9 is negative 5. You must type in the ordered pair. 0, negative 5. If you just say negative 5, you're wrong. Because the y-intercept is an ordered pair. The x-intercepts. We can see that we are intersecting right here at negative 1 and at positive 5. Now we have two x-intercepts. So we need to say negative 1, comma 0. So that's the first x-intercept. Then we press comma to separate our two answers. And the other one being from the picture, we see it's 5, 0. All right, and there you go. I know there are a lot of little pieces to that, but we've already done 3 problems before. You've seen the videos. Go back and watch those guys to refresh to see how do we come up with all these different pieces of information. And just as a reminder here, coming back to this last example, if they were to ask you where is this function increasing or decreasing, you see that as you trace along with your mouse or your finger, you are decreasing from negative infinity to an x value of 2. So that would be negative infinity to 2, parentheses. And then you are increasing from 2 to infinity. As you trace along here from 2 to infinity for those x values for that interval, that's where your graph is increasing. All right, question number 4 is kind of the same thing. Notice that it is opening down because of the negative, and you see it here with the picture. Yeah, finding that y-intercept may be hard to see, but of course this is algebra. We can always plug in 0 to find that y-intercept. Axis of symmetry, once you get the vertex, you're going to be set. So we shouldn't have any problems with that one. Okay, so here's a good one for us. This is x minus 5 squared. So x squared is this guy. When you have the minus 5 inside, you do the opposite of what you see. So even though I see a negative 5, I'm actually going to go to the right 5 units. So I'm just sliding to the right 5. I'm not going up or down, just sliding to the right 5. That gives me the vertex at 5, 0. Now they want me to graph this. Alright, so I'm going to click on this. Notice that the parabola tool is a 2-point parabola tool. So when you click to graph, you're going to first graph the vertex. So the vertex is over here at 5, 0. And then you need to pick just any other point. Because once you do that, the program knows to make a parabolic shape. So here's my suggestion to you. Notice that there is an understood 1 in front of that set of parentheses, which means it's going to have the same normal parabolic shape. Which means if I go to the right 1 and I square that, I go up 1. And I can hit enter on the keyboard, and there we go. Notice that it follows the rest of the pattern here. If I go out 2 units, 1, 2, I'd be up 1, 2, 3, 4 points, 4 units, right? And so it's going to give me that nice parabolic shape because there's no stretch, there's no compression, it's just the normal shape. And now I'm going to click check answer. Well done. The axis, now notice here, this says type an equation. Your axis of symmetry is x equals. In question number 3, it had x equals in a box, and you just typed in the number. But here they want you to type in the equation. So x equals, and we see that vertical line is going through x equals 5. The domain, again, this is not new to us. It's negative infinity to infinity. You know what? I'm going to go ahead and select all of this and copy it because I'm sure I'm going to need to use that again. My range, we've seen this with domain and range with functions. Bottom to top, you're starting here at 0 and you're going up. Now you are including that value of 0. And don't think it's going to be a parenthesis because the graph happens to curve. No, you are including over here this y value of 0. So that's included, which is why we use brackets. So the open interval of the domain over which the function is increasing. That's what we were just talking about. If you trace with your mouse or your finger, you are actually decreasing until you get to x equals 5, and then you're increasing. So the interval over which it's increasing is going to be open interval, which means parentheses on both sides. It's going to be 5 to infinity. And then it's going to ask you the open interval over which it's decreasing. Well, that's what we have here on the left side. We're going down as I trace from left to right. Again, always as you go from left to right, what are you doing? Are you decreasing or are you increasing? So I'm decreasing over that interval from negative infinity to 5. Check that. Good job, Mr. Craig. Next question. And they're going to ask you the same thing here. Okay. The only thing different is that your vertex is shifted, not just left and right, so it's shifted to the left. Because we see a +3, but remember that means we go to the left, the opposite of what you see. And then whatever's outside this -1, you do exactly what you see. So that means we're going to go down 1. And now that we have the vertex, it's pretty simple to go to the graph. So click on the graph, click on the 2-point parabola tool again. Your vertex is -3, -1. And then from here, let's see, 1 squared is going to give us 1. And there's our graph. Nothing weird is going on here. There's no stretch, there's no compression, there's no reflection. Okay? And now we just need to check our answer. Now remember, if you've got a point wrong, you don't have to clear everything. You can click this point and move it somewhere else. If you realize that you have the parabola graphed correctly, but it's just located in the wrong spot, you can click the graph itself and you can slide it up and down, move it wherever you want to. So if you realized, oh, I was supposed to have moved it over here, then you can do that. Let's go ahead and put it back where it's supposed to be. Check that. All right. The axis of symmetry here, again, it's the vertical line, and you've shifted this vertical line to the left 3 units, so it's the vertical line x equals -3. The domain, well, it's a good thing I copied, so now I can paste that, because we know the domain for any polynomial function is all real numbers. The range, the lowest this guy gets is right here, so that's bracket -1, and it goes all the way up to infinity. So you start here at -1, and it goes all the way up. The largest open interval of the domain over which the function is increasing. Okay, so again, the point, the x value where you change from increasing to decreasing or vice versa is right here at the vertex. So you see that we're decreasing until we get to an x value of -3, and then we're increasing. So it's going to be increasing from -3 to infinity. And then the open interval over which we are decreasing, you see as we come from -infinity up to the x value of -3. So trace along here. From -infinity, you are decreasing, going down, 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 until you get to an x value of -3. And then you stop decreasing, you change, and you start to go up. All right, so we're going to skip a couple of questions here. They're all kind of the same. The minimum value of the function, well, what's the lowest this guy gets? And when we say the minimum value, we're talking about the y value. The lowest this guy gets is a y value here of 7. Right? And it's all about the vertex. So when you have a parabola that opens like this, the vertex is the minimum value. When it opens down, the vertex is the maximum value. And a lot of times we want to know what that is. Because if I were to take, say, an object and toss it into the air, I could use a quadratic function to model the path of that, and I could find that vertex. And that vertex is going to tell me the maximum height that object is going to get. All right, so let's talk about these guys real quick. So let me change away from that for just a moment. All right, so you have this in the notes. But let me go ahead and remind you of this. So we have the quadratic formula, which is -b plus or minus the square root of b squared minus 4ac all over 2a. Now, this expression that is inside the radical, okay? This is called the discriminant. Okay, it's just called that. I don't really know why it's called that. Typically, we call the expression inside of a radical the radicand, but this guy's a special guy. He's the discriminant, and the way this discriminant goes tells us what kind of solutions we can expect to have from solving a quadratic equation. And once we know the kind of solutions from solving a quadratic equation, if they come from a function, we know if we're going to have x-intercepts or not. For example, if this discriminant, b squared minus 4ac, if this value is positive, then we're going to have 2 x-intercepts. Because it's going to be positive, that means we're going to have 2 real solutions, one plus and one minus, and that's going to lead to 2 x-intercepts. If, however, this discriminant is equal to 0, then we only have 1 x-intercept. Interestingly enough, that 1 x-intercept is also going to be the vertex for the parabola. But if the discriminant is something less than 0, and we've seen this with the last couple of examples that we've done, if that discriminant is less than 0, that means it's negative, and we end up with 0 x-intercepts. And remember, the reason for that is because if you have the square root of something that's negative, you end up with imaginary numbers. Okay, so these lead to non-real solutions from your quadratic equation, quadratic function. So taking this information, we can figure out the kind of graphs that we expect to have. So, for example, if I say this, if I tell you that A is positive, okay, and I tell you that B squared minus 4AC is negative, same example that you have in your notes. Since A being greater than 0 leads to a parabola that's opening up, okay, so we get this picture in our minds. B squared minus 4AC is less than 0. What does that mean? Well, this means, looking up right here, that means that we have no x-intercept. So we're opening up, but no x-intercept. So if you had to draw a quick sketch of what this looks like, a parabola opening up, but not crossing the x-axis, could be anywhere up here. You can draw a parabola anywhere that opens up, as long as that vertex is above the x-axis. Because if your parabola is opening up, but the vertex is below the x-axis, if I move this below here, you would end up crossing the x-axis 2 times. Here is the other example that we have in the notes. So if I say that A is less than 0, which right now you should know, if that lead coefficient is less than 0, that means it's negative, which means you have an upside down parabola. Parabola that opens down. And let's say that the discriminant, b squared minus 4ac, is greater than 0. So this means right here that we're opening upside down, and this means that we have 2 x-intercepts. So if I had to draw an example of something that would fit this, okay, I've got to be upside down, but I have to cross the x-axis. That means that your vertex ends up being above the x-axis. So it could be anywhere above here. It could be in quadrant 1 or quadrant 2, and you're going to be opening upside down. So you are crossing into different values. Okay, so in the last example, you were positive, but you couldn't cross, so that meant the vertex had to be up above. Here you were negative, so you're opening upside down, and this told you that you had to cross 2 different times. So let's go back and look at these homeworks. So here this says A is less than 0, which means it's going to be opening upside down. And this part right here, the b squared minus 4ac, is also less than 0, which means that A less than 0 is opening down. B squared minus 4ac less than 0 means that's going to give you a negative inside the square root, which means you have imaginary solutions, which means you don't have x-intercepts. So I need to be opening upside down with no x-intercepts. And that looks like it's going to be this guy right here, right? He's opening down, no x-intercepts. This guy's opening up, so that's not A less than 0. This guy opens up, so again, still wrong. This one opens down, which satisfies A is less than 0. However, you have 2 x-intercepts. And b squared minus 4ac, that discriminant, tells you that you shouldn't have any. You check this. Excellent. And one last one. Wow, this is the exact same one we just did, which is kind of weird because it's a completely different question. All right, so less than 0 means open down. This means that I have no x-intercepts, so it's still the same kind of thing. Now, again, this stuff is kind of random, so you never know what you're going to get. Check it. Okay. I've got a 64.7. Yeah, I know I need to work on that. But I'm going to let you guys do that. So now I want you guys to jump into the homework and knock out homework number 32 based on what you've done in the notes. All right? So, can't wait to see what happens in the next section because it's one of my favorites.